So, welcome back. So this is the second part of the uh, lesson that was covered during the vacation class. So again, we're just going to continue on linear regression, but this time around we'll be seeing how to interpret the results. So I will first take you through some of the important notes that you need to take note of before we get to the interpretation of the results. I only have one activity to show you, but I've tweaked the activity a little bit so that it can cover everything that was covered in class and even what was not covered in class. I've added some addition to the table. And some of you that were in class, you'll be able to compare with your slide and see that there is a little bit of addition to the table. But nevertheless, it is still important that you go through this session to understand how to interpret a linear regression result. So, but like I said in the beginning, we first need to understand the basics. So we say linear regression is a common methodology used for demand estimation. Uh, it To perform demand estimation using linear regression, we first collect data on the relevant factors and the corresponding demand levels for the product. These data can be obtained through surveys, experiments, or by analyzing historical sales data. Remember, for those of you in class, I said we are doing this for forecasting purpose, and we do need existing data before we can proceed with our analysis. But it's very important that those data are reliable data. You're getting it from a reliable source. So it could be from your organization. And remember, or from any statistical institution, or but probably more importantly, it must be a reliable or recognized institution. You are getting your data before you do your analysis. But in our case, for managerial economics, I'm presuming that you will be getting your data from your organization and then you analyze it to forecast or predict uh, demand based on the price. Now, if we go by the formula here, we say demand is equal to beta naught plus this beta naught is the intercept. We'll talk about that in the next slide. Beta 1 multiplied by the price plus beta 2 multiplied by advertising plus beta 3 multiplied by income plus a standard error, the E. Now, you should understand that any of these factors besides the price, the other variables like advertising and income and any other variable we want to add like B4, beta 4, multiplied by, let's say, for instance, geographical location. Any of those factors can, in collaboration with price, can affect demand. That is what this linear equation model is trying to say. That is, we can, in our previous example, in the previous video, we're only looking at linear demand function, looking at the intercept and the price, and we have just one parameter affecting the slope rather affecting the price. If you remember, it was QD equals to A, but in this time we have a negative sign indicating that there was an inverse relationship with price and the slope was here. But that was just a linear demand function explaining relationship between price and quantity demanded. But in this case, we are adding other factors. Now we are saying that there could be advertising, income. I could go on to add location, geographical location, gender, which may not be a real scenario, just to indicate that there are other factors besides price that can affect demand. But more importantly, what you want to know is what are these beta 0, beta 1, beta 2, beta 3. Let's see in the next, and the standard error as well. Let's see what it is in the next slide. Now, here we say beta naught or beta 0 is the intercept term. I already emphasized on that earlier, and it represents the demand level when all other factors are equal to 0. So whatever the intercept is, if all other factors are 0, the intercept uh, will be the quantity demanded. And we will try to prove that this is not true by looking at the hypothesis. More on that in the next slide. The coefficient beta 1, beta 2, and beta 3, it could be more beta 4, beta 5, depending on how your model is, represent the sensitivity of demand to price, advertising, and income, respectively. This is based on our model. And the last one, the error term plus E, represent the random fluctuation in the demand equation, which cannot be explained by the linear regression equation. So the error term is something that we cannot fathom. We cannot understand what are these other factors that can affect demand, but we cannot calculate it. We cannot estimate. No, not that we can calculate it, but we cannot estimate it really, because what we are really trying to do when it comes to demand is that we are trying to reduce likelihood of making an error, right? Reduce the error term. But anything that cannot be explained is also captured in the regression model analysis. Now let's further understand what we'll be going through, or what the result is going to look like, and what we will be reporting. Now, first and foremost, let's look at the following statistics which are commonly reported. First, we have the R-squared, we have the t-statistics, and I also have down here F ratio. I will talk more about that, the p-value, and the standard error, which will come in the next slide. Let's start with the R-squared, for instance. So I will read it out, and I will also explain in layman terms so we can all be on the same page here. So the R-squared is this statistics measures the proportion of the variation in the dependent variable y, and in our case it will be q, that is explained by the independent variable x. In our case, this will be beta 1, beta 2, beta 3 in the model. It ranges from 0 to 1, where a value of 0 indicate that the model explains none of the variation in y. And the value of, sorry, when I said the variables x, I meant the price, income, and advertising. Those are the variables we're considering. Apologies. And the value of 1 indicates the model explains all the variation in y. A higher value of R-squared indicates a better fit for the model to the data. So whenever we are reporting the result, the first thing we look out for is our R-squared. Now, in your result, if you see that the R-squared is high and is closer to 1, it means that the model has a better fit. So if you're getting something, I will say like a rule of thumb, if your model is from 70 and above, it is good. Otherwise, it's not really good. When it's 60, 50 and all that, and 30 is extremely bad. You can as well just stop, because what is saying that your independent variables like price, advertising, and income if your R-squared is low, it does not explain the impact on the quantity demand in our case, which is y here, the dependent variable. So what we are saying is that literally, like, your price, your advertising, and income does not have any influence on your quantity demand. So you can as well stop analyzing your result in that kind of situation if it comes to that. Now, t-statistics. Now, how do you know? Okay, again, let's read it. This statistics measures the significance of each independent variable in the model. It indicates whether the coefficient for the variable is significantly different from 0. A larger absolute value of the t-statistics indicates that the variable is more significant. Okay, I will come back to F ratio. So in each variable, each independent variable, that is the price, the advertising, and income, we need to read their coefficient score, their t-statistics score. Now, the assumption, hypothesis, not null hypothesis, is that they are 0. So we need to prove that this is not true. So when we get the t-statistics, the absolute value, that is, you don't take cognizance of the sign, we report it by looking at the p-value of that t-statistics. So if we have a t-statistics that is significant, and how do we know if it's significant? We only look at it by estimating the p-value, which we will talk about later. That is how which when the p-value is less than 0.05, that's how we interpret the t-statistics. But just remember one key term here. The t-statistics represents each of the coefficients. It represents the how significant each of the independent is to the model that we are trying to interpret here. But when it comes to the F ratio, the F ratio has an overall significance of the regression model. So what the F ratio does is that the result of the F ratio or the F statistics, when we do the analysis, it captures all the data of all the independent variables. It summarizes them, how important they are to, or how they fit with the model, the dependent variable, which is the quantity demand in our situation. And again, if you want to explain the F ratio, you need to look at the p-value of the F ratio. The p-value of F ratio, if it's less than 0.05, then we can say that it is significant, and that is what the p-value is here for. These statistics measure the probability of obtaining t-statistics. I focus on t-statistics here because we are looking at each of the coefficients individually. Assuming that the null hypothesis is true, that is, that the coefficient is 0. The null hypothesis is always going to say like the null hypothesis is 0. So we have to reject the null hypothesis that it is not 0. So a smaller p-value indicates a stronger evidence against the null hypothesis and in favor of the alternative hypothesis that the coefficient is more than 0. It's not 0, right? In general, the p-value of less than 0.05 is considered statistically significant, indicating that coefficient is unlikely to be 0. So if your p-value is less than 0.05 for the t-statistics, that's when you report that your t-statistics or the coefficient is significant. That is, of the independent variable in the model. That's for t-statistics, but if it's for the regression model itself, you report the F ratio. If you see that the p-value of the F ratio is less than 0.05, then you report that the regression model itself, the whole model itself, is significant. Okay, now let's move on to the last important note. That is the standard error. These statistics measure the variability of the coefficient estimate. So like I said, a lower standard error indicates greater precision in our estimate. So you want to always have a lower standard error. You don't want to have an error that overshadows your old model. So the lower it is, the better your model is. So all these statistics influence the factors such as they are influenced by the factors such as the sample size, the distribution of the data, and the presence of outliers. I must also note that before we start computing our data, you must always remember that based on reliability of your data source, you must also consider some basic assumption of linearity, homoscedasticity, and this is just basic econometric modeling before you start your data analysis. You also need to do a normality test. If I'm not mistaken, yes, you have to do a normality test of error. All this are very important, but maybe not. I'm not focusing on that on the lesson today, but those are things that you need to assume before you start analyzing your data. But for today's video or lesson, we are just trying to focus on how to interpret a good result. Let's assume all these assumptions have been met. Now you have to interpret the result. Now let's say in the next slide, let's look at an activity here. Interpreting linear regression results, empirical linear demand function. This is the activity. So you will find similar in your notes, but with just a little bit of tweak. A major smartphone manufacturer is interested in determining the factors that affect the demand for its latest smartphone model. The company research department has developed a linear demand function that includes the price of the smartphone, the average consumer income, and the price of competing smartphones. The demand function is represented as Q, you can say quantity demand, equals to A, which is the intercept, beta 1 multiplied by the price, plus beta 2 multiplied by the income, and plus beta 3 multiplied by the price of competing smartphone, where all this stated here. Now, moving on, you can always use your notes. I want you to have your notes by your side when you're watching the video so you can follow through. Okay, so moving on. So this is what you're asked to do. This is the results section. Using the information from the regression analysis provided, can you analyze how each variable in the demand function influences the quantity of smartphones sold? Okay. B, are the coefficients significant? And C, can you compute the point elasticity, price elasticity of demand when the smartphone is priced at $800 and the average consumer income is 50,000 and the average price of competing smartphone PC is 750. Okay, now let's see how we're going to interpret this result. So here is our result. Now let's take a look at this result. Apologies for the video blocking the p-value, but you can go through your notes. You can tell that all the p-values are less than 0.05. Let me just take note of that if you haven't. So you can look at the dependent variable here, Q, which is quantity demand. Here the R square is given as 0.8532. Already I can tell that the R square is 85% or 0.85, which means that it is a good fit for our model, so we can proceed to interpret. This is our F ratio, the absolute value 46.29, but the P value of the F ratio that is for our model is 0.0001, which also means that it is significantly it is significant, statistically significant, because this value is less than 0.05. We have 36 observations, that is, we have 36 different variables that we're looking into, of reports that we're looking into. Now, in the next slide, I should take you through how to answer the first question, okay, which is using the information from the regression analysis provided. Can you analyze how each variable in the demand function influences the quantity of the smartphone sold? So literally what we're asking you here is to explain what are the parameters, interpret all these parameters, yeah, how each of them influence the quantity of the smartphone sold. Literally, you're just supposed to interpret them. So here is it. So beta 1, the first parameter. By the way, the first, the intercept, the first intercept B naught is represent the parameter of the intercept. Now beta 1 represents for 22.75. If you go back to your slide and revisit the table, you will pick it up under the first column on the parameter intercept result. You will pick it up that where the negative 22.75 explain the inverse relationship between price and quantity demanded. The negative sign indicating that there is an inverse relationship. Beta 2 is a positive parameter, showing you that the smartphone is considered as a normal good. Based on the income now, we are looking at the income elasticity, and beta 3 represent the parameter for the cross price, and it explains that the parameters is a substitute good. Okay, we can move on to the next slide. Now, are the coefficients significant? How do we report if the coefficient is significant? Remember, I told you first you have to look at the F ratio of the regression model. We already discussed that it is significant because it's less than 0.05. 0.0001 is less than 0.05. But let's look at each of the p-value. Now we can see the p-value. My face was blocking it earlier. Now you can see the p-value result. You can see for the intercept, it is extremely low, yes. For the price, how do we do this? We first look at the T ratio, okay? We look at the value here, 7.98. Is it statistics? Is it statistically significant? Yes, 0.0492 is less than 0.05, so it is statistically significant. That's how you report it. Is the income significant? Here's the T ratio again, 11.61, but the p-value of the T ratio here is 0.0001, which also less than 0.05. Similarly, for price competing firm smartphones, this is the T ratio, 42.76, and 0.002 is also less than 0.05. So we can confidently say that all our coefficients in this model are all significant. So it's based on the p-value results. Now, the last part is to look at can you compute the price elasticity of demand with respect to the company smartphone price when the smartphone is priced at $800, that is the price. Average consumer income is $50,000 and the average price of the competing smartphone is $0.50. Now, if you recall, this is our formula, the model. We have quantity demand equals to the intercept, beta 1 multiplied by the price, multiplied by each of the independent variable, income and price competing smartphones. So we can substitute this value into the equation. And this is our quantity demand. This is our intercept, 80.45. Remember, beta 1 is the parameter for the price, and here it is, multiplied by our price, which is given in the question, 800, plus, but don't forget there is a negative sign here for our parameter for the price, plus the beta 2 for income, multiplied by the income, which is also provided. The parameter for price competing is also given here, 175.3, multiplied by $750, which is also given in the question. And when we find all this, remember this positive and negative, so this will be a negative when you multiply them. But the first thing, you have to follow the rule of BODMAS. So it will first be 22.75 multiplied by 800 to give a negative value, and so you have a negative value here, and when you multiply the positive, it will be negative. I remember some people might struggle with that. So when you do that for others, also 750 multiplied by this before you add, and 800. You have to do 50,000 multiplied by 0.11025 before you do your addition. So multiplication before addition, simply. And when you do the addition correctly, you should get this value of quantity demand. Now you're going to use this value, quantity demand, to calculate the elasticity of demand. So this is what we're going to get. Now it's going to be price divided by quantity demand multiplied by the beta 1 in our case of price elasticity of demand, which is representing the change, right? It's like the slope. So it's price multiplied by quantity demand and multiplied by the slope, in this case beta 1. And when you do that price elasticity of demand, 800 is given in the question multiplied by the quantity demand that we got when we did all the addition from the model, and we got negative multiplied by the beta 1, okay, multiplied by beta 1. This is the result, the elasticity, and 0.15, which is inelastic. When we look at the absolute value, it is inelastic because it's less than 1. You do the same thing, income divided by quantity demand, multiplied by the slope, in this case beta 2. Again, 50,000 is the income multiplied by the quantity demand multiplied by the beta 2, the value, the parameter, remember in the column, in the question. When you multiply that, you get this value. It means our good is it's a normal good because it's also from 0 to 1 is positive. And here is the Cross price elasticity, price of competing firm, competing smartphone divided by quantity demand multiplied by the slope, beta 3, and what we get is the 750 divided by the smartphone competing firm multiplied by the quantity demand, again multiplied by beta 3, and this is what we get, a positive value, meaning that our good is a substitute, obviously. So that wraps up what we discussed in class. So I want you to be able to interpret your result. Read your notes on elasticity is very important so that you can understand what this class is all about. All right, thank you.